Good evening, madam. Oli Kumar, madam. Good evening, madam.
Good evening, madam. Good evening, everyone.
Good evening.
Madam, before starting the session, I just want to give an announcement, madam.
Sure, please do.
So, good evening, all participants. Today is day 5, session 9. And today we'll be having 2 sessions, session 9 and session 10. And tomorrow we'll be having 3 sessions. It starts from 2 p.m. to 3:30 p.m. sessions 11 and 3:30 p.m. to 5 p.m. session 12. And the last session is 5 p.m. to 6:30 p.m. So everyone try to attend all the sessions because some are lagging in your attendance as we need 80% of attendance for certification. And kindly provide all the correct details while giving the feedback on attendance. Because we are having some missed data, it's not for providing the attendance, you should all give the proper data. Yeah, thank you everyone. Now it's my privilege to invite our session's esteemed speaker, Dr. V. Valli Kumari Madam, to deliver her presidential knowledge and guide us with her vision for faculty development and research on topic generative AI for incident response and automation. Madam, please start the session, madam.
Yeah, I'm loading my presentation. Just give me a minute.
Sure, madam. At 6:30 p.m. to 7:30 p.m. and 7:30 p.m. to 8 p.m. there is a validity session. So once everyone clear that assessment online test only, you will be getting your certification of this ATAL FDP. Attendance 80% and you should clear the assessment test. Thank you.
Okay, can you see the screen now?
Yes, madam.
No, madam. No, madam. No, madam.
No?
No, madam. No, madam.
It's visible, sir, to us.
Madam screen.
Yeah, sir. It's visible like generative AI for instant response and automation.
Yes, sir. Visible, sir.
Okay.
It's visible, sir.
You have to click on Valli Madam screen, sir.
Got it, Prasad?
No, madam. You can carry on, madam.
Okay, madam. You can proceed, madam.
Okay. So, yeah, good evening, everyone. And so let us go to the next session, generative AI for incident response and automation. And meanwhile, in yesterday's talk, I also wanted to show you the implementation of LLM and differential privacy. But as it was already late and people were busy logging out, I thought I'll cover it today. So if time permits, I'll cover the implementation, the code portion of yesterday's session too. Well, today's session is about generative AI for incident response and automation. Well, this generative AI for generating malwares or generating software code is already popular, but uh, application for incident response and automation is still in its very nascent stage. Okay, people are just started. They have started using this generative AI for incident response. So initially, we'll go through what is instance response and why this is required and all this stuff. And then later on, we'll also go through a few case studies. So let us briefly also work out on what this incident response is.
Excuse me, madam.
Yes,
Your screen is not visible presently, ma'am.
uh, I think a few people it is visible, right?
Now it is not visible, madam.
No, madam.
Is that so? Okay, let me share it again. Now,
Now
Yes,
it is
sir.
visible, ma'am.
Yeah.
how, what could be the reason? Okay, so these are some of the topics that we will be visiting in this session. So, why incident response is required, and what are the challenges in implementing them, and what is generative AI, and what are its applications in cybersecurity. Yesterday we have seen LLMs with privacy. Now we'll be totally into cybersecurity, and how Gen AI is incorporated into the life cycle of instance response, and about the future trends. Why at all instance response matters? So, instance response, it helps in minimizing damage and the recovery time. So, what does it actually mean? What is instance response? Yeah. What is instance response? No answers. Say there is a cybersecurity incident, and say the network is down, or the server has crashed, or there is some malware which has brought the whole organization's enterprise edition, you know, down. It has pulled it down. How quickly you are able to come back to normalcy? Okay, and then the next portion is like, how do you find out what is the root cause of that incident, security incident that has happened? Okay, so this very important for an organization, because the organization's network has to be very robust so that attacks do not happen. And in case, unfortunately, if an attack happens, a security incident happens, then how resilient it is, how quickly it can come back to normalcy. That is what we mean by resilience. So, IR, the policy that you have in your organization, it
Ma'am,
helps.
excuse me, madam.
Yeah.
Sorry for interruption. It's echoing, madam. Actually, like if there are two devices nearby, it will be echoing.
Mm, okay.
Yeah, one should be muted.
Now?
It's good, madam.
Yeah, I have logged in with another device to just check if my screen is visible to you or not.
Yeah, now it's good, madam.
Yeah. So, if you have a proper policy in place, then you can minimize the damage and also the recovery time. Okay, the time it takes for an organization to come back to normalcy. So, that is the recovery time. And similarly, the impact, the loss due to that security incident has to be minimized to the extent possible. Similarly, protecting sensitive documents, sensitive data, and intellectual property of an organization is also equally important. So, if there is a data theft, or if somebody has, you know, exploited a vulnerability in an operating system, or had some privilege escalation of the account and somehow started using it, okay, then it is likely that important documents might be lost or some intellectual property of that organization may get lost. It also helps in maintaining the customer trust and brand reputation. Say we have seen occasionally that WhatsApp is down. Okay, as a couple of years ago, we have all experienced it. Okay, for around an hour or 2 hours, WhatsApp was down and there was an outage. And look, the next day there were headlines in the newspapers. So you need to maintain the customer trust, and the brand reputation is also important for a company. Then ensuring regulatory compliances means government norms and all we need to comply with. So a bank server like entity, if there are incidents, okay, security incidents happening, then yeah, it is required that such servers have to comply with the government regulations, okay, to avoid any penalties. So, and also minimize the loss in case certain incidents happen in such financial institutions. Then strengthening the overall security posture through whatever experience the company has gained over the years. So they, you can, you know, consistently improvise your systems in the organization. So, what are the challenges in the current incident response systems? So, data overload. You can see when you are you really want to perform incident response perfectly well, you have to uh, you know preserve or maintain all the logs of all the activities that are being done throughout the enterprise. Okay, so now manual analysis of all those logs becomes very difficult. So people started creating some data mining or machine learning models uh, to mine these logs, or recognize or identify certain patterns in these logs which are of interest. Then the types of threats are getting sophisticated. So the cyber criminals who are actually the sources of these attacks, they're becoming more and more uh, advanced. And when it takes when you consider an organization, there is severe shortage of experienced cybersecurity professionals, and also incident response analysts. Okay, so if an organization's network is down, somebody has to be there who actually should uh, troubleshoot or uh, track down what is the root cause of that uh, outage or server crash or OS failing, whatever reason. Similarly, uh, time constraints. So you have to do things very quickly, almost in no time. So rapid responses, they often clash with manual processes. Similarly, there are tools to perform, so the scope of the tool is limited. You need to use multiple tools to debug down to a particular root cause. So why AI powered incident response? Why generative AIs or artificial intelligence models have to be deployed in this incident response uh, domain? Enhanced speed, accuracy, automation is possible, and scalability. You can handle vast amounts of data, like log data, okay, and also the alerts that have risen, the exceptions that have risen, without increasing the number of people. And what is generative AI? Just for the sake of completion, so traditional AI models, they might detect patterns like we have been doing with data mining models, okay, and uh, deep learning models, regular deep learning models, or neural networks in that sense. So Gen AI can create patterns. Okay, traditional AI models, they detect the patterns, but generative AI can create the patterns, generate text, images, code, or other media that resembles the real world data it was trained on. So we can have some, this is general technical stuff related to Gen AI. Like we have transformers, so they are the neural networks which enable parallel processing of the sequences. So LLMs we have seen yesterday, they are already built in models with lot of training already done. So models with billions of parameters trained on vast text data sets, capable of generating human-like text and understanding the context. Similarly, RAGs are also getting very popular. Uh, so it's like you can have an LLM as the base, and then you can train it. Okay, you can augment it with your own data. Okay, so the advantage is like you can have an up-to-date knowledge base, and accuracy automatically improves, and it also reduces the hallucinations because it has more information. Now in security per se, so we have talked about incident response, uh, now generative AI, and how can you fusion them out? So generative AI's journey, uh, till very recently, as I told you in the first slide, it is still in an nascent stage. But from theoretical concepts, it has started moving into practical aspects. And people started deploying the models. And uh, there is a lot to happen in the next coming couple of years. So, automation, detection, threat intelligence, proactive defense, these are some of the stages. So early applications, they focused on just basic automation, something like generating the scripts for routinely performed tasks. Like you want to do some log analysis, you can make use of uh, Gen AI application and then create a script for performing that log analysis. Then it went on to anomaly detection and detecting the malwares. Okay, and now it is moving towards threat intelligence, and you are also getting into dynamic incident playbooks. So that means these models are continuously learning and then uh, going to the next level every time they encounter new information, new samples. So when you consider instance response life cycle, you can have Gen AI in every phase. So in the detection phase and the triage phase, detection and triage, or containment and then eradication, analysis as well as investigation, recovery and post incident operations. We'll study in depth each of these. So it goes on like this. Just to give you a gist, in incident response, like if a security incident happens in a large organization, the first thing is that some security incident has happened is to be detected. Okay, why the system has shut down? So is it due to some hardware failures, or is it some malicious activity, or intentionally somebody has done it? We need to detect it. Okay, so automating the alerts, identifying the anomalies, and you may see a lot of incidents sometimes, and we need to prioritize them. So the highest, impact incidents have to be handled first, and followed by the remaining. And the next thing is, whenever an incident happens, the first thing is you have to see that it doesn't spread to, say, if there is a malware already in the network of a campus, it doesn't spread to other segments of the network. So containment, you have to somehow see that it is restricted to that particular region. And then eradication, removal of it, and then analyze and investigate how actually this has happened, what has resulted in this incident. So what are the prior actions that were done in the network or within the system, and then recovery and the post incident operations. So the same thing which I explained you is just put in a neat tower like thing. Okay, preparation. We need to have a policy, an IR policy, and some procedure, and training for potential incidents. So you need to have some people who are trained for regularly happening issues, security incidents. And you also have to have an organization policy, like some personnel in one section of the office has uh, somehow come to know that something is wrong and is happening with his system. So the policy, there should be a policy for the organization which says somebody has to be the single point of contact. This person who has identified how to report the phone numbers, the formats, the templates, all of them have to be in place. So next is detection and analysis. Okay, and then containment and eradication, so that you limit the damage and now find out the root cause of that security incident, and then restoring all the systems to normal state, and have your services of your company extended in full mode. And then once you have detected a security incident and you have recovered, now next thing is you have to see, document all the things that were done to bring back the network to normalcy. Okay, and you have to have some process improvement so that such a security incident doesn't happen again. So let me take you to a few case studies. Can you see the screen?
Yes, madam.
Hmm.
Response case
So
study.
let us work out some 3-4 case studies which I normally use in my cybersecurity and digital forensics course. Yeah. So if someone can volunteer and read this, I'll be happy. Let this be an interactive session. Anyone? Or you want me to read? Come on, volunteer. ఎవరైనా చదవండి ఇది. Unmute yourself. Prasad is permitting the organization team.
They can unmute. If anyone is interested, they can unmute.
No? Look, you'll lose the opportunity. Okay. So this is a case.
Uma madam.
Wedding planning.
Yeah. Come.
This incident response case study involved a client that managed accounts for their clients. After about $1 lakh was transferred from an account, the client contacted us to determine what occurred. More importantly, their insurance company requested that a forensic analysis be performed to indicate whether the loss of money was due to an inside job or whether it was due to a hacked computer.
Okay. So the thing is like, say you are the company and you have a client. Okay. That client has a lot of other clients, right? And
Yes,
so, yeah. So some $1 lakh was transferred from an account and that client contacted you. So your customer who runs a web portal or who runs a company has got a lot of clients and some $1 lakh was transferred from an account. So he contacted
ma'am.
you to determine what happened.
What has occurred? Yes, ma'am.
Yeah. So the insurance company requested that a forensic analysis be performed. Means you want to find out what is the cause of that security incident,
Yes,
because
ma'am.
you want to know how that $1 lakh was transferred. Okay, was
Yes,
it an insider job? Means somebody from within the company did it, or it was because somebody hacked the computer and it got it.
external.
Yeah. Okay,
Inside or
continue.
external?
Continue. Continue.
Yes, ma'am. Analysis of Analysis of the computer indicated that a keylogger was installed on the computer. A keylogger is an application usually running unbeknownst to the user that records all keystrokes. The keystrokes can be recorded in a file to be transmitted later or may just be recorded in the memory, again to be transmitted later. The data may be in plain text or may be encrypted. However, before we go further, let's take a step back to see how we got to this stage.
Okay, so what has happened? So what is the root cause of that transfer? So it said a keylogger, a malicious software, a malware was installed on the computer.
Yes, ma'am.
Okay, what does the keylogger do? So whatever keys are pressed, they are recorded in a file and they'll be transferred to a C2 server, means an attacker's computer. So the data may be in plain text or encrypted. Okay, now, so we have seen what the problem is and what was the root cause. Now, how did this get discovered? Please continue.
Yes, ma'am. Digital forensics analysis of the computer indicated that during a lunch hour, the computer operator was doing some wedding planning. Various apparently harmless websites were visited. However, not all is what it seems. when you go to a website, whether it is CNN.com, ChicagoBears.com, or Facebook.com, you get delivered content from the main site. However, quite often the advertisements you see on the page come from other websites who pay the main website to advertise or place content. So while you are looking at the home page for CNN.com, you are actually being delivered content from a whole host of the other sites at the same time.
So what does this mean? Somebody, an employee within the company,
Yes,
during the lunch time, he used the office computer and was doing some wedding planning. Okay,
yes,
he
ma'am.
was visiting a lot of websites. So one thing we have to bear in mind is some website like Facebook or CNN.com or some other website may have a lot of advertisements as well. Okay, and
Yes,
within the same portal, not all the content in all the panes, okay, comes from the uh, server you are connecting to. So that server, that program, that website program might be having a lot of windows. So the whole web page is divided into several sections, and some sections the content comes from the company's web server, and the remaining sections, remaining windows, they get the data from advertising companies or third party websites. Okay,
yes, ma'am.
though you are logging into a particular website, that website content plus it their
Third
advertiser,
party
yeah, third party content also comes here.
website. Yes, ma'am. Yes, ma'am.
So in this case, yeah, next.
It- In this case, it was another site that was the culprit. Some
So Facebook
advertise
was not the culprit. The other site which was showing the advertisement was the culprit. Come.
okay. Some advertisement was coming from a website that had been hacked. This is not an uncommon occurrence, and we refer to it as a drive-by download. The hacked website exploited a vulnerability in our client's computer in order to gain control over the computer. The vulnerability was one that was known, and Microsoft had released a patch for it months or maybe a year prior. So, which is the reason why security experts like Vestige urge clients to patch their computers regularly as part of a multi-pronged security posture. After taking control of the computer, a keylogger was downloaded, installed, and made persistent, meaning it was set to launch every time the computer was rebooted.
So normally people don't update their operating systems or browsers or other softwares, right? So this remote hacked website was used through that. What was done? The vulnerability in this computer, in this your
Client's computer.
client's computer, was exploited because they were not updating their OS. Okay,
Yes,
and
yes,
and then
they
what
gained
happened?
control.
Yeah, so they gained control of the computer, and a
Yes,
keylogger malicious software was downloaded and it was installed and was made
installed.
persistent. Means
Persist.
it can stay for a long time.
Long time.
So that means even if you reboot the system, it comes back again.
Yes,
Yeah.
ma'am.
Next.
This keylogger was not your ordinary, average, everyday keylogger. It was an efficient keylogger, just like your efficient Vestige forensicator. This keylogger concentrated on just those websites that dealt with banking or other financial information. Not only would it be log keystrokes, it also logged the website title and address in the keylogger file. This additional logging made it easier for the hacker to pinpoint the information he was seeking.
Hmm. So
Fortunately,
what happened here? That keylogger, that malware, is an intelligently written program. It's not a regular keylogger. It just doesn't log every key. It logs keys of only the websites which are related to banking or some financial information.
financial.
The regular websites, the data is not logged. Okay.
Yes.
So Yeah. Now, fortunately, the client had two-factor authentication.
Yes,
So the IP address of that computer was registered with the bank, but the hackers wasn't. Two-factor authentication. The IP address of this particular computer was registered with the bank, and the hackers wasn't. So now the person through the keylogger program could get the credentials, the login name and password. Okay, now that hacker tried logging in from his own computer, right? So now
yes, ma'am.
what was done from the hacker's computer when he tried to log in?
IP.
The hacker was prompted for a second password, which
Second
was
password.
unknown to the hacker because the client never had to enter it. So client entered only login name and password. Okay, the next is the IP address is automatically taken. But the hacker has only login name and password. And unfortunately, in this case, the bank, upon noticing that someone was trying to enter under our client's account from an unknown IP address, they suggested to the client to change the second password. Okay, so
Yes, ma'am.
the client innocently types in a new password which the bad guy doesn't have, and a couple of days later, the bad guy was using the client as a personal ATM. So, what is the twist here? Anyone? You can post in the chat window. So, keylogger to hacker వచ్చి login name password he could retrieve. But
Yes,
then the second password was also required. So the thing is like the bank identified it that they are logging in from an unknown IP address, not the regular IP address. So they said, come on, enter your second password. Okay. So what did the client do? He doesn't know that the keylogger is there, right? So he typed
yes.
in the second
Second
password.
password
Now
also.
keylogger is already there. So what happened? Hacker could also get
Accessing to his account.
second password. So he was using their client's account as a personal ATM account. Just a second. I'll put the charger on. So now, so there's an incident management, right? So what should be done? So we were studying. The first thing is detecting the incident. Okay, that $1 lakh was transferred is detecting the event. Next, identifying. Okay, what the root cause is what was done, and then post the incident. Okay, what should be done? The client gets an information. You would send the client some information saying always keep your computers up to date, have antivirus software installed, practice other proactive security measures. Okay, and then don't use your office computers which are used for banking transactions for visiting regular general websites. Don't use emails in that computer. Don't open other documents or don't open websites. So these are the post incident, you know, documentation and guidelines that will be issued to all the employees. Okay, mail can be circulated, a circular can be made saying don't do this, do install antivirus software and all that stuff. Okay,
Yes,
so this is all. uh, After an incident happens, how do you detect that an incident has happened, and what are the post incident operations and the documentations that need to be done? Okay, we'll come back. So I have about 4 case studies. So we'll come back to one case study later on. Now you know. So the preparation phase is about developing policies, procedures, and training for potential incidents. Okay, so the company has to have some policy, who to report and all that, and a procedure, how to report and all that, and some people who are trained to handle such events. Then detection and analysis, like our case study said, it detected a keylogger, so there was a process for it. Containment and eradication, so that no more money transfer will be done later on. And then recovery, so make some complaints, make some backups and all the stuff. And then document all the lessons learned, and then improve your processes. So there are phases like detection and analysis, like identifying the threat, and containment, limiting the damage, right? And then restoring to normalcy. Then post incident activity like learning and improvement. What are the common incident types in cybersecurity? Same phishing. Phishing is done through emails, or right. Uh, you may also have voice calls, phone calls asking you for OTP. That is called as phishing. Okay. Smishing is like you get an SMS with a link and you're asked to visit a website and enter your credentials. You may get some cloned websites, you may share your credentials. So, suspicious links, unusual sender, you're not aware of him, and regular greetings. So, all of them are sent through these emails. This is called as phishing. Then, malwares may be installed, like the keylogger one we just read. So, malicious software designed to disrupt, damage, and gain unauthorized access is called as malware. And what is the result like? The systems may get compromised, like the client system got compromised, somebody got control over the thing and then installed the keylogger, took over the control. And how do you detect? With slow performance, there are lot of pop-ups and lot of network activity. You can see a lot of traffic going in and out of your system. And sometimes it could be due to insider threats. So negligent actions, malicious actions by the employees. Sometimes former employees have got usernames and passwords with them. So they can do some data exfiltration. They can transfer important files. Okay, next. There could be AI models making unfair or discriminatory decisions due to biased training data. So there could be reputational damage or legal or ethical issues. There are traditional IR tools, like we have seen, most of you must be aware of this unit, security information and event management. Normally we teach these in the forensics classes, right? Network security classes. So there will be a centralized logging service, and now based on that data, you'll be able to analyze. Uh, but the setup is very complex and there are many false positives encountered, and there is no automated response. There are also other tools like SOAR, security orchestration, automation and response, and extended detection and response, but SIME is very popular. So now that you know what incident response is, now we now get into generative AI in the IR life cycle. So we have seen different phases: identification, defense, detection, response, and recovery. Right? So most of these phases. They are performed by sign-like tools. And response and recovery, like analysis of the data that you found, all the artifacts that you found in the systems where the incident has happened, analyzing, investigating, okay, reporting, all these are usually done manually, though sign-like tools are used for the first three. Okay, now generative AI can be applied at the places where you know, uh, manually the data is analyzed. Yeah, so we can use generative AI after gathering the information to extract meaningful signals from noisy alert streams. So there are a lot of alerts that get raised. Out of them, you have to find out the ones that are really important. So in that case, we may make use of the GenAI. So it gives analysts a high signal view instead of a wall of logs, and produces audit friendly reasoning behind the groupings, and ensures that triage focuses on the high business impact first. So something like this, we picked it from one of the manuals for Gen AI in security. So just go through the diagram out here. Okay, so you can ask the model, Gen AI model, for with proper queries, proper prompts, and then it can give you out the results. Then comes narrative anomaly detection across the telemetry. So AI connects disparate events into a cohesive story, identifying deviations that mimic human analyst reasoning. So you have a lot of information in silos. Now Gen AI can help you aggregate all the information and come out with a story. Okay, some with connecting dots. So it's not just like, for example, in Google, mail services, you must have seen the email filters, spam filters. Okay, there the spam filters make use of certain keywords. So if there are certain keywords in the subject, or in the mail it is coming from certain mail IDs, or uh, some ambiguities, some patterns in the mail IDs, or in the body of the mail. Okay, in the text that is written in the mail, if there are some patterns, then the spam filters use those keywords and then classify it to be spam or not spam, right? Uh, but here, Gen AI applications, Gen AI models, if you are using, it goes much beyond just the keywords. Okay, that is the advantage. Similarly, you can also make use of these Gen AI applications to fusion lot of data from multiple sources. Like you can check the logs, you can check the emails, endpoints, even the traffic data. Okay, and then come out with some uh, suspicious activity connecting all these sources data. Again, alerts from different systems. You might be using a lot of tools. Now alerts from different systems may also be merged and you can come out with a better decision. Yeah. So AI instance database. So like our regular malware data sets and all that stuff, you can have a central repository for AI related incidents. Okay, so why AI related uh, incidents data is important? So incidents and the report that is generated. Okay, so if we consider all of these factors, incidents are different events, distinct events. Okay, and each incident is supported by one or more reports, and each report will have a lot of documentation, lot of artifacts included into it. Okay, evidences, and what is the context of that security incident that has happened. So every incident will be supported by a report, and the report will have lot of information. Okay, now here is where AI systems can become important. So for every incident you have a big detailed report putting all the incidents together. Okay, you can now make the AI model have more knowledge base. So, and we also have uh, taxonomy, okay, which classifies the incidents and the harms or the impacts, right? And there might be people who are submitting this data, okay, and so there forms a database of AI incidents. So what are the issues with the AI models? So what are the kinds of uh, challenges that we need to address? Bias and discrimination. So we have seen related things in our yesterday's talk too, but yeah, bias and discrimination. What could be a bias? So a spam mail, okay, when given to an AI model, can be intentionally, uh, you can make the AI model say that particular mail is a genuine mail, okay, instead of marking it as spam. Yeah. So bias means there comes in some unfairness, right? So then we may have some privacy violations. So the data that the model should not collect is actually collecting it, and then misinformation or security exploits and uh, manipulation of the decisions. Yeah, we can have, we see a lot of case studies getting published, like we did for the classical IR. So it could be like uh, there are a lot of documented cases of wrongful arrests where individuals have been detained based on incorrect facial recognition matches. Okay, and frequently impacting minority groups due to inherent biases in the algorithm and the training data. What does this mean? So certain facial patterns, they will be automatically classified as uh, wrong individuals, wrong class of individuals. And beyond these individual incidents, there are broader concerns regarding mass surveillance. Okay, so that means even when you are in groups, certain data is collected, and that is like, your fundamental privacy right is violated. So AIID, it logs all such incidents and gives some crucial data points for policymakers as well as researchers for responsible AI, responsible development and deployment of these AI models. We have seen a lot of deep fake scams and misinformation. So these AI incident databases may record all such scams. So this data can be used now for LLMs, augmenting the already trained model. Augmenting means you already have trained the model on the data set existing. Now this extra AI incident database can improvise the LLM's performance, okay, to get new plans for the incident responses. Similarly, you can also have incident similarity search. Say some October last year some incident happened, then Jan Feb some incident happened. So you can actually search for certain past events and then predict potential harms, and then try out for some strategies to minimize the uh, impact, loss impact. There are many open source projects, okay, designed. You can just go through the stuff. So assume you have a company, an incident response company called Vestige, and just let us go through one case study. Can you see the screen? Can you see the screen?
Yes, madam.
Yeah. So let us go through this. Usually the work that hackers perform is similar to picking a lock, breaking open a window, or getting into your house, right? So here in this case study, the hacker walked into a door that was left open and unmonitored. What does this mean? Say, a company, a consultant, cybersecurity consultant company, say Vestige. We are giving it a hypothetical name. So Vestige is a company, and our client contacted us because they were seeing unusual activity on their network. Examinations of their logs, network logs, indicated that someone was logging into their servers and properly authenticating themselves. No malware, no trojans, nothing. The bad guys just got into the network. So now the cybersecurity forensics company Vestige was hired to determine what may have been taken and whether the hacker still had a foot in the door. So now the cybersecurity company remotely imaged the servers involved. You know imaging? So they take a snapshot, the running snapshot. Then remote imaging is a technology that is fast and efficient in these types of matters, especially when the evidence is located hundreds or thousands of miles away and needs to be preserved now. So the data is preserved on encrypted drives before being shipped back to our lab, right? The reason behind the encrypted drives is that if UPS loses the package, or the trains carrying the package drives into a mountain, your data is safe because with the encryption, no one is going to get it, right? So Vestige can remote into the computer that needs to be preserved from anywhere in the world at any time of the day and preserve the data present upon the computer. After the data was preserved, we got on to examining it. We confirmed for the client what they believed. The hackers had entered into their network using an administrative account that had a very weak password. Look, what is the root cause of this? So the client observed there was a lot of network activity happening. Something is getting transferred from their systems. Okay, so when they complained and these people examined the whole dump, they found out that they had a very weak password. So there was no Trojan, no malware or any additional account. And once the client changed the password, the hackers were logged out. There was no transfer of anything. Now look at the twist. This is what has happened. Anyone help me out to find out what has happened? How did the data get transferred from the client's computer to the attacker's servers?
They breached the data by the website, madam.
Hmm? No? You can see here right away. They didn't use HTTP protocol, no website. What did they use?
The FTP and cloud sites, madam.
Yeah, they were transferring files through the FTP
FTP, yeah,
software.
file transfer protocol and cloud sites.
So what did they do? They compress the data. The hackers, they compress the data in the victim's computer into a RAR file. Okay, zip file. Okay. Uh, Now, but the problem is the client already has a firewall. So it will stop. Okay, it will stop any data that is being transferred through FTP, right? So what did he do? He just renamed the RAR file as JPEG. He named the RAR file as the JPEG file. So was he using FTP or HTTP? Was he using HTTP or FTP?
FTP, madam.
So firewall is able to detect any data that is transferred through FTP. So he wanted to transfer the data, the RAR file through FTP, but then he found out that client already has a firewall. Okay, client has a firewall which can detect transfer via FTP. So he actually compressed the data into RAR file to transfer over FTP, but because of the firewall, what did he do? He renamed that RAR file to extension JPEG. Now picture can be transferred, okay, even through the website. So he visited the client's website and downloaded data as if they were downloading a legitimate picture. So which protocol they were using? Even though they thought of using FTP, because of the firewall, they changed it to a JPEG file as a single file and then downloaded it from the client's website, like any other website picture. So luckily the data was not very important, so it was not that issue. But then what is the lesson that they learned? To audit their password policy to see that if it is being enforced to changing the passwords regularly or not. Okay, this is the post incident reporting and documentation, and circulars will be released like every 60 days, every 90 days. The password has to be changed and all that stuff, or the password has to be minimum this many characters long and combinations of alphanumeric characters and all that stuff. Okay, so any questions till here? Any questions? Any questions?
No, ma'am.
Okay, so uh, is Swati there online?
Ma'am, actually, the mute was muted to everyone, ma'am. The host didn't give permission, actually.
Okay,
So some couldn't, maybe Swati ma'am couldn't speak, I think.
she's not there.
I'm not sure, ma'am. I'm just
Can
checking.
she share the screen? Or I'll do that. So yesterday's session, I'll share you this link. You can study and implement. Okay. Okay. So I'll make that LLM privacy code open, and you can visit my Kaggle and then use it. Okay. So yeah. So I think we'll close it for now. If there are any questions, I'll be happy to answer.
Okay, thank you, madam. And we extend our heartfelt thanks to you for delivering a highly informative and insightful session on generative AI for incident response and automation. So, your expertise and clear explanations gave participants a deeper understanding of this critical domain and greatly enriched today's session. So, we are eager to engage with you again in future knowledge sharing opportunities, madam. Thank you, madam. Thank you so much.
Thank you.
And dear all participants, the next session will start at sharp at 7:30 p.m. We can take for 5 minutes break, 5 to 7 minutes break, and tomorrow's session the timings are from 2 p.m. to 3:30 p.m. Session 11, day 6, session 11 from 2 p.m. to 3:30 p.m. It starts at 2 p.m. 3:30 p.m. and it will be continuous 3 hours, 3 sessions. Like the next session will be 3:30 p.m. to 5 p.m. and thereafter by 5 p.m. to 6:30 p.m. So whoever having less percentage of attendance, you can recover by attending 3 sessions continuously, such that you can get your participation certificate. And that would be provided only once we complete the online test and feedback. That will be at 6:30 p.m. to 7:30 p.m. And from 7:30 p.m. to 8 p.m. there will be a validity session. Thank you. We'll meet again at sharp 7:30 p.m. So I welcome back everyone here. Now I would like to give a brief introduction to our esteemed speaker of today's next session, Dr. BBM Krishnakant sir. Sir has 21 years of experience in teaching, research, and IT industry, and he is currently serving as co-founder of BTOPP IT Solutions Hyderabad. He earned his Bachelor of Engineering from SRKR Engineering College, Bhimavaram, and obtained his MTech and PhD degrees from Swami Ramanand Treath Marthwada University, Nanded, Maharashtra. He has rich academic and research experience, having served as a professor at Anurag Engineering College, principal at Hindu Engineering College, Guntur, and as a research scientist, artificial intelligence and research and development at Srivahini Institute of Science, Vijayawada. He also possesses extensive IT industry experience, having worked as a data analyst at NetVision Cybernet, senior data scientist at programming.com, that is lead data scientist, Gen AI consultant at Persistent Systems, and senior technical manager at HCL Technology. He has authorized 16 publications in reputed international journals and holds 3 national patents in the area of machine learning. Now it's my privilege to invite our sir to deliver his presidential knowledge and guide us with his vision for faculty development and research on the topic tools and technologies for AI powered CTI along with practical applications by using generative AI, that is with the architectures of RAG agentic frameworks.
Thank you. Thank you, madam.
Yeah.
Good evening, everybody. Can you hear me?
Yes, sir. You're audible, sir.
Okay, thank you. Today, I will share sharing my screen. Okay. Please allow me to share my screen. In today's sessions, I want to give a deep knowledge about 3 important areas, and everybody is speaking about generative AI, Gen AI. So before learning Gen AI, everybody should know the basics of NLP. See, in AI, there are 3 types of data. One is structured data. Generally, we use Pandas framework for processing these tabular data, which are very structured. But coming to unstructured, which is contain text data, speech data, or image data. So there is no proper technology developed for the past 10 years back. Now, whenever you want to process text which is unstructured, it should be done in a different frameworks, not using a structured framework which are usually done using pandas, which are just rows and columns, and there are values in a tabular format or a CSV files. So to process text, which is very complicated information, because most of the information in the real world is text information. So everybody do communicate with text, maybe whatever language it is. For in this case, I am taking English as a language. So everybody wants to communicate with text information, text data. So lots of information is there in the world. So analyzing and performing analysis on this text data, you need a separate a technology or a framework, which is called NLP, Natural Language Processing. In NLP, generally, if you observe, everybody is using chatbot or chat GPT. Everybody is using chat GPT for all their daily use cases. You type a prompt in the text box, and our chat GPT will give the response. So based on the prompt, it is giving the output. But if you want to develop a chat GPT on your own, maybe your own chat GPT like OpenAI or Gemini 1.5 or Llama 2, which are developed by different technologies, you should clean the text. Without cleaning, you can't develop a good model, good AI model, so that AI model will give the response perfectly. So internally, whenever you type a command in the prompt in ChatGPT, it is doing some data cleaning or text cleaning. So how to perform the text cleaning inside the ChatGPT is the major important step before trying to learn generative AI concepts. So this is the basic steps. Everybody should know what are the pre-processing steps. What are the steps you should follow in order to have a very good clean text. It is nothing but text cleaning. So suppose you want to construct a building, you should gather the material. No? Suppose sand is there. So you should clean the sand. You should remove the unwanted material other than the sand. Like that, in the text also, if you see the text in internet or if you see any text data in internet, it is not a perfect. It has some unwanted symbols, unwanted content, or maybe some letters will be there between the words, or there may be some unwanted symbols will be there. So we should remove those unwanted symbols, unwanted text before applying to a very good LLM model for performing the processing to get the output. So this NLP pre-processing is the first major step. Everybody should learn and how to process the text so that you can clean the text. I will explain both the theoretical part and I will have a hands-on how to do coding in Python. What are the basics libraries required for processing the NLP, your text data, so that it will be a clean text before applying to any AI model like a ChatGPT or any OpenAI model for your own tasks. Here, if you consider the NLP pipeline, so this is the steps for performing NLP pre-processing. First is text wrangling and pre-processing. The second step is text normalization. And third is word embedding. So these three components comes under pre-processing the text. The first three, text wrangling and pre-processing, text normalization and word embedding, these are the pre-processing of your text, cleaning text. And coming to the fourth block, it is building a model. It is completely about your AI model. So AI model, building AI model, initializing the model, training the model, and testing the model and evaluating the model. So the last 5 sessions is only about the model training, model testing, and evaluating the model. So there is nothing to do about the model because we are using pre-trained models already. ChatGPT is there, GPT 4.0 or GPT 3.4 Turbo. These are the models, LLM models available in OpenAI. They are already trained with huge amounts of data. So we will use those pre-trained models with the text you are giving as an input. So here let us concentrate on the first three blocks. What is how to perform text wrangling or pre-processing, how to perform text normalization, and how to perform word embedding. So these are the three important steps before developing any AI model. See here, see, see the most of the data, it will be a messy. So we have to clean the data, which is unstructured text data. So you may ask me, what are the noises added in the text? So there are many types of unwanted items added to the text you see in the tweets or some other internet websites. First is hashtags. Hashtags is a hash symbol before a name. So those are not important. So how to extract those hashtags and how to clean URLs. There will be some URL links will be there before any sentences or words, and how to remove emojis, some symbols, some smileys, how to remove digits. Suppose some digits may be there between letters, and how to remove punctuations, and finally how to remove stop words. See, there are stop words are nothing but the words like a, yan, in, this. So these words are stop words, so they are not important. Because you can ask me, sir, why you are removing this a word, and, it, this? Because these words are does not give meaning for the sentence completely. Because we are processing a lots of data, thousands of data, you should try to minimize the meaning with few number of words. So these stop words are not does not add much meaning. So I should remove the stop words in the sentences you are working, maybe the paragraphs. So these are nothing but the what are the noisy material which are present inside the text data. Coming to text normalization. So these pre-processing tweets, it is coming under text wrangling and text pre-processing. Coming to text normalization, what is text normalization? See, suppose if you observe text in books, generally there will be words will be there will be sentences, there will be paragraphs, and there will be pages, there will be chapters, and combination of chapters is a book, complete book. See, if you read the text, you will read one word at a time. You can't read the complete sentence at a time. So if you see this simple sentence in computer science canonical means, see, I am reading every word one by word. So you have to extract the words from the sentences. That is the first task. So you have to extract each word separately, and that is called tokenization. It is called tokenization. And every word is called a token. It is a vocabulary used in NLP. So a token is a single word in a sentence. In is a token. Computer is a token. Science is a token. Canonical means. So tokens are nothing but a meaningful words which are, when they are combined, it will form a sentence. A sentence which are combined, it can form a paragraph like that. So you should try to extract every word from the sentences or paragraphs, and that technique is called tokenization. So the first technique you should perform in text normalization is tokenization. The second technique called stemming. Stemming means, suppose in English there will be a lengthier word, long word. Suppose if you say running is there. So running is a different word. I want to convert this running into a root word called run. See, my idea is to reduce as many characters as possible. So I will make the word as short as possible so that I can reduce the memory inside your computer. So running, I should convert to a root word called run. Hitting, to root word called hit. So I will remove the last suffixes ing or ate, and that technique is called stemming technique or lemmatization technique. So it is also text normalization. You are reducing your a large word to a root word so that you can reduce the space required for storing that word while you are pre-processing your text data, because you are dealing with lots of words So you should make it as small as possible. So the technique is called stemming technique. And the other technique in stemming is called lemmatization technique. It is nothing but converting your a word into a root word. Suppose banking is there, it converts to a bank, like that. So you're removing suffixes which are not important, that much important in many situations. Sometimes it is needed, but in many situations it may not be that much important if you want to extract the complete meaning. And another technique called sentence segmentation. I told you tokenization is extracting words from a sentence, and sentence segmentation is, suppose a paragraph is there, so a paragraph contains sentences, so I should extract each sentence which are separated by a full stop or a comma or a question mark. So how to perform sentence segmentation, sentence separation, and how to perform spelling correction, spell correction. So these are the text normalization techniques which are generally followed for cleaning the text. Coming to word embedding actually it is a very complicated technique. Here, NLP has came into existence, has raised a lot by developing techniques for word embedding. How to embed the word? Suppose, see everything a computer knows, you know that everything computer can understand only digital data, not text data. So how to encode your words into vectors? How to represent a word into a vector format, which is a combination of some numbers. That is a challenge people has faced. So it is a sorry, it is a great challenge people has faced to represent a word in a vector format. How to represent a word in a vector space, a word space. And people have developed many techniques. They have developed, first technique is one hot encoding, which is very famous, old one, which is a, a sparse technique, one hot encoding. The second technique is bag of words. Third technique, glove. So these are some of the word embedding techniques people have developed. And how to represent a word into a vector format is the challenge. Suppose if you say one word, call a bank, B and K. Bank can be a bank where you deposit money. It can be a rubber bank. Is right? So both represents the same letters, but it has a different meaning. So how to represent a bank when you go to a bank, or I am standing besides a rubber bank. See, bank is a word, but it has a different meaning in different situations. So embedding this word bank is a challenge. Where it is located. So the words before that word bank and the word after the bank should be considered as important while you develop a embedding for the word bank. So bank in going to a bank to deposit money, when it is placed in that sentence, it has a different embedding numbers. And the same bank, when it is there, I'm standing in the beside the river bank. So that bank word will have a different integers because it is have a different meaning and it has a different format. So that is the challenge people has faced. So how to represent that in a word space? And word embeddings are the most important techniques for converting or encoding our words into a vector format so that I can easily represent them in the word space so that I can do processing with those embeddings. So computers will understand only word embedding data, not the text. So finally, your text should be converted into tokens. Your tokens should be converted into vectors, which are word embeddings, which are used for giving as input for the any AI model or LLM model. So these three are the important pre-processing steps before giving data or a text to your LLM model. Let us see the some practical use cases. How, see, this is the word space. How your LLM, how your words are there in the word space, they can represent in a different space. Let us see some practical applications, how we can do some. I'm opening Google Colab. Can anybody see the screen?
Yes,
Can,
yes, sir.
can,
Yes,
can
sir.
you
Visible,
see?
sir.
Can you see that Google Colab? Okay, I think I'm sharing. Code is there. I think I'm sharing some other screen.
Yes, sir. Only File Explorer there, sir. Google Color not visible, sir.
Okay, that's why. So I want to convert. So I want, because I'm seeing some other. Okay, wait a bit more. One minute, please. Now it is visible?
Yes, sir.
Okay, okay. Sorry, actually, I'm sharing some because there are multiple screens. Okay. See, let us see here. It is a Google Colab. See, I'm importing some libraries. Here, the first part is how to identify the parts of speech of every word in a sentence. Suppose what is a noun, which word is a noun, which word is a verb, which word is a proper noun. Like that, first of all, should identify the parts of speech for a given sentence. For that, let us do a small application using NLTK. There are two libraries available for performing NLP tasks. One is NLTK, Natural Language Toolkit, and other library called Spacey. So these are the two libraries available for performing NLP types of coding in Python. So I'm importing NLTK. See here, import NLTK, and I'm downloading the punctuations NLTK. So inside NLTK, there will be all the punctuations, commas, and I will have all the parts of speech available in NLTK download averaged perceptron tagger. So it is a library, it is a class where you will have all the tagging, all the parts of speech information. So I will import. So I'm running here import analytica and analytica.download of punct underscore tab or analytica.download of average perceptron tracker. ENG means English language. So for different language, it will be a different word. So let us take a small example sentence. The small boy ate the pancakes from the restaurant. It is a one sentence I have taken. So sentences are represented by a this string format. So sentence is equal to a string format by a double quotations. So I want to perform to divide this sentence into individual words. I want the small boy as a separate tokens. So for that, there is a method called NLTK.word tokenize. See here, NLTK.word tokenize of the sentence. And I will store in a variable called token. See if I run it, what is giving, sorry, sentence I have not run. I should run the sentence. Then see the small, see they are separated by a comma by single quotation. See the small boy ate. See like that I am dividing your sentence into tokens using a method called word underscore tokenize. You have to remember these methods which are coming under analytic library. See the same way I want to find out the parts of speech of every word. What is the, what is small? So for that there is another method called analytic dot pos underscore tag. Pos means parts of speech tag of a token. See, I'm finding the parts of speech for every token, not the entire sentence. So token here, I'm got the token here. So for the token, I'm finding the parts of speech. So if you run it, see, the is a determinant. Small is a JJ, it denotes adjective. JJ is symbol, which is in IBM Watson. So you have to refer to what is JJ. Boy is a noun. NN means a noun. Eight is a verb pronoun. The is a determinant. So pancakes is a NNS means plural noun. From is a preposition. So like that, I will have the parts of speech of every token. So this is the method for finding the parts of speech of every word in the sentence. Suppose if you don't understand what is the small jj, you can refer to the IBM Watson parts of speech page where you can have all the so this is the parts of speech tag sets. What you can see here. See DT means determiner. NN means noun, singular noun. NNS is a plural noun. Like that, you can have the meaning for the quotation given in that. JJ means a adjective. Here 8 is a adjective now. So JJ here it is a adjective. So like that, we can find the meaning of every word. See next step is told you I will remove the stop words. No, stop words are nothing but words like in, the, a. So how to remove the stop words? For that also there is a some methods available, and that method is called stop words. Download of stop words. So it will contains all the stop words you can remove. So it is given in the stop words method or a class where you can remove those stop words. So from corpus. Corpus is the large repository like a dictionary of English. Import stop words and stop words dot words of English. So in this list, I will have all the stop words. So these stop words I will remove, and I will have only the words without the stop words. So let us take a small paragraph. So this is a long paragraph of text. Okay, here I will remove is, I'll remove a, of. Okay, these words I will remove, and I will remove, which is a stop words. So how to remove? Okay, so let us see. Let us run it. See here. So this is a removed. This remained long. So is removed from the paragraph. Paragraph is there. Of text is removed. Paragraph text. See, sometimes is there. Important is there. Words is there. Like is there. Apple is there. And is removed. And is removed. And after the and, mission is there. See here, these stop words I can remove from the paragraph using this method available in NLTK. So these are very, very important techniques for cleaning your text, removing stop words, finding the parts of speech of your a sentence of text, how to perform it. So these are very, very simple one word command, one line command, where you can extract the content from the text. It is called data or text wrangling or text preprocessing. So let us understand text normalization called. See, I have told you that text normalization means stemming, removing the suffixes from the words. Only I will maintain the root word. Running is there. I want only run. ing I will remove because it is unnecessarily I'm adding extra characters which are not having that much meaning. You can ask me why you are removing. Sometimes that ing may be needed, but in many cases, these suffixes are not have that much meaning while you understand the text for the AI model. So, see here, sometimes sometimes we see English letters, there are some words which are clitics. They are called clitics. Suppose he will, he apostrophe il, I will, I apostrophe ll, didn't, did apostrophe nt. So these are some typical words you will see in English lettering. No, because if you perform tokenizing these words, he is there. Suppose, for example, he is there. See here, sentence, he is a German Shepherd. He, if you perform tokenizing, what it is happening? He is one word, yes is another word. So yes, in single form, it has no meaning. What should be he, is. So actual meaning is he is. But you are writing he apostrophe s. You are writing didn't. Did apostrophe nt. But actual word is did not. I apostrophe l. Actual word is I will. But you are writing I apostrophe ll. If you perform tokenizing of these words, you will get it I and other word is ll because it is no meaning. So if you perform tokenizing these type of words, it is having a meaningless tokens. So you have to convert these words into a meaningful format, and that is called contractions. Expanding that word into a meaningful word, and that is technique is called contractions and expansions. So how to perform this contraction is very, very important because if you don't do contractions, you are converting into tokens. You are grabbing each word from the sentence and storing in a separate format. But if you don't do expansions, you will have a wrong word which has no meaning. Here example, he is there, yes is there, where yes in a single word has no meaning. It should be is. So for that, the methodology is there in Python and how to perform those techniques I will explain you. So the same way, import NLTK I'm running. And from NLTK.tokenize, let us see punch tab. From NLTK.download, I'm downloading all the punctuations. See, he is a sentence. I'm far from word tokenize of this sentence. He is a German Shepherd. There are, see here, he is one word, yes is other word, a German Shepherd. Full stop is a separate character. So it is dividing, it is separating full stops, spaces also. So space is a character, empty space. It is the word tokenize technique. You are separating words. Even though space is there, it will perform it. Here, see here, let us take, actually it is sentence tokenizing. Separating, here past you have seen word tokenize. How to perform sentence tokenize? Suppose if you give a paragraph containing many lines, I want to separate into sentences, and for that there is a method called sent underscore tokenize. See, I'm taking a long word which is containing two lines. Okay, one line is hemisphere question mark. It is one sentence. The second sentence is Rintin was a German Shepherd rescued from WWT. Full stop. The second sentence. The last sentence is there are some of the smartest dogs. So there are three sentences. So I should get three sentences from this paragraph. I want to separate them into sentences which are separated by a full stop or a comma. Let us see. So send tokenize, not word tokenize. Word tokenize means it will give every word. Here it will give every line which are separated by a separators like a full stop or a comma or a question mark or a exclamation mark. See here. See, it is giving. See, did you know? This is one word. It is in the form of a list. So did you know? It is one sentence. Second is rent in the second sentence. They are some of the smartest talks. So there are three sentences which are separated using sent tokenize. Very, very simple commands. Simple commands. You should know this fundamentally. So let us see. Let us take a sentence which is having some critics. See here. Let us install contractions. So contractions is a library for performing these contractions for converting your word like critics into a expanded word. See here, I've taken a word. She apostrophe s going for a walk. Jack didn't go. See, and they'd they they would actually they would see they have written they apostrophe d. That's all. I apostrophe m. I apostrophe ll. I will. It is. That's that is. See, that apostrophe s. See, these are critics. So if you separate into tokens, they will be one word, D will be another word. They would, but it is they'd. She is one word, S is other word. So if you separate in tokens, they are not having any meaning. So I should expand into a meaningful format. Let us see. See here, if you observe, see, she is going for a walk. What is happening? C apostrophe S becomes she is. See here, she is going for a walk. Jack, what is there here? Jack didn't. Here it happened. Jack did not. And here they apostrophe D. What is happening? They would. See it converted into they would. And I am sorry. I apostrophe M. I am sorry. I apostrophe LL. How it converted into? It converted into I will. I will. See, so if you separate these expanded words, it is separated in a meaningful way. I, comma, will. So it is meaning. Suppose if you don't do contractions, then your tokens are not meaningful. So this is a simple command for performing or removing these special words called clitics in English. They are called clitics. So which are short form of that word, because it will take less time to write, because if you want to write a long paragraph, so you will reduce the shortcut. These shortcuts are not allowed if you convert them into tokens, which are single separated words which are meaningful. Otherwise, your LLM can't understand what is YADL, what is yes. So you should properly transform these shortcuts into a expandable format. So a simple command is able to perform it. It is not a complicated commands. Very easy to understand and very easy to implement. Next, coming to lemmatization. These are very, very important, very important to understand, become a generative AI expert. So without knowing this, you can't a big good generative AI. So you should know how to pre-process the text data and how to clean it. So coming to lemmatization, so lemmatization is a very important technique. So I told you that how to remove the suffixes for a word, how to have a root word. So there are many techniques, and one is a lemmatization and stemming. Here, for that, in NLTK, the same thing, import NLTK. In NLTK, there is a called NLTK.stem import WordNet lemmatizer. It is a class. WordNet lemmatizer is a class for performing lemmatization. So, NLTK.download of WordNet. It is contains all the words in a dictionary in a repository. So it download the package WordNet. In WordNet, there will be a WordNet lemmatizer. Please remember these commands. So you have to by heart it. Very simple words. So I will call this WordNet lemmatizer by a variable called lem. Lem is a variable where I'm calling the class WordNet lemmatizer for performing lemmatizations. So let us take a word stockings. So stockings is a word. So stockings is a word, but the root word is stocking. So I'm removing yes. So suffixes are removed. So lem dot lemmatize. So lem is a word dot lemmatizer and dot lemmatize of the token. Token is nothing but the word stockings. See here. See, stockings became stocking. Suppose let us take another a word running. I'm running. Running is there. What happens? See, running becomes running. Suppose runner is there. So sometimes it happens. So in some situations, let us take bankings. Relational, let us take. So giving the root word maybe. Let us see here. Findings become finding. It is removing yes. So this is the purpose of wordlet numerizer. See, let us take, see here, let us take two strings. The girls sang louder. The bankers banked at other banks. How it is performing lemmatizing these words? The girls should become girl. Banker should become banker here. Bank should be banked only. At other banks, see the word banks came many times, but it is properly performing lemmatizing. I'm getting some error here, maybe some server error. So it will convert into a root word. Let us see. Let us take another example. So here I told you there are two techniques called stemmer and lemmatization. I have not included stemmer, there is other program. So let us execute now. So there are three stemming techniques called Porter stemmer, Lanchester stemmer, and other stemmer called. So there are three techniques. One is a Porter stemmer. So it will remove the suffixes. See, let us see. Analytic.stem import Porter stemmer. See, Porter stemmer of stockings become stock. Jumping became jump. See here. Let us run here. So Porter stemmer.stem of stockings became stock. Same way, Porter stemmer.stem of jumping became jump. So it is removing the suffixes. Ing is removed. S is removed. Let us see. Bunnies. Porter.stem of bunnies become bunny. So is removed. So organization becomes organ. Organization shortcuts. So there are three techniques for performing stemming. One is a Porter stemmer, Lanchester stemmer, and third snowball stemmer. So these are the stemming techniques for performing word cutting, or it is called chopping the words. So how we chop? So there are around 120 rules you will follow. So it is following about 120 rules are there. So how to cut the suffix part of the word. So how to remove es or s, whether to remove e and s or whether to remove only s. So there are some rules are defined, and based on the rules it will chop or it will strip the suffix part of the a big word. So let us see the Lanchester stemmer. So it is other stemmer, Lanchester stemmer. For analytic.stem import Lanchester stemmer. So I'm calling the Lanchester as Lanchester is equal to Lanchester stemmer. So Lanchester.stem of organization. So what happened here? This became org. So Lanchester stemmer is giving org for organization, but Porter stemmer is giving organ. So it is based on the rules, because here it is using 120 rules, but Porter stemmer is using only 60 rules. So it is a very old technique. but Lancaster stemmer is a modified version of a Porter stemmer. So it is correctly giving. See, bunny, previously it is giving BU and an I, which is not meaningful. Here it is giving BU and an Y, which is the modified version of a Porter stemmer called Lancaster stemmer. It is a class written in stem, analytica.stem. Please remember this, analytica.stem import Porter stemmer or Lancaster stemmer or snowball stemmer. So you can call any classes which are present in a stem library, analytica.stem import Lancaster stemmer. Let us see snowball stemmer, how we do snowball stemmer. So from analytica.stem import snowball stemmer. See here in snowball stemmer is a modified version where you can define the language. Here you have defined a language as English. Maybe it is used for other French language also. See, let us see snowball.stem of ordination is organ. Digitize, give digit. Favorable became favor. Limitation became limit. See how it is chopping the suffix part of the a word. So which are very, very important for saving memory in processing these text data. If we compare all the three techniques, see here all the three techniques I have compared in a single. See here for bunnies, what is bunnies is there. For potassium it is giving bunny. For Lancaster stemmer it is giving bunny, BU and an Y. For snowball it is giving BU and an I. For organization organ, ORG, organ. So comparing the three stemming techniques while transforming our a word into a root word. So these are very, very important concept you should understand while pre-processing the text. Okay. So coming to next session, so we have seen about so I have seen how to perform tokenization, how to perform stemming, lemmatization. Sentence segmentation means how to segment a sentence like word tokenization, how to separate sentences. Spell correction all automatically it is doing. So these are the important pre-processing steps in NLP. Now let us coming to the second part, which is RAG, retrieval augment generation. See, RAG, suppose, I think everybody now in industry, they're asking to do projects using RAG. Suppose if you see LLM, I'm using a chat GPT. You can ask me why RAG is used. RAG contains retrieval augment generation, a technique for giving some extra content for the your large language models like ChatGPT. Suppose if you ask a ChatGPT, suppose you want to ask some questions on your own documents, own private documents, like your PDF documents is there, which you only have that in data. But our ChatGPT does not know your private documents, which are only available with you only. It is not available in internet. Your ChatGPT can give response only for the data it is trained. it can't give output for new data, which is real-time data. So that's the major drawback of OpenAI LLMs. If you see, OpenAI LLMs are trained only with data until 2021. Before 2021 only, it can understand. After 2021, it don't know how to answer the questions because it is not trained with the current data. That's the drawback. So how to give that information for our LLM? Suppose it does not know anything about your private data, private documents. Suppose you want to perform a search engine with the documents of Swarnandha Engineering Colleges only. All the data will be only within the Swarnandha Engineering College repository. So nobody knows. So I want to perform a search engine chatbot. Suppose if you ask a question, what is the percentage of Krishna studying in third year IT in Swarnandha Engineering College? If you ask a question for the ChatGPT, it does not know the answer because the data is there within the PDF documents inside Swarnandha College repository. So how to develop a search engine to answer question for our own documents? How to do it? It is a very big challenge. For that, they want to train your LLM with your own data. But training LLM with your own data is a impossible task because it requires a lot of money, lot of resources. So the technique called RAG is used for performing search engine within your own private documents. That is called RAG. So how to do it? Let us see the architecture and overview. And it is a very, very important problem every company are implementing. Suppose I'm working in my own company, I have own documents, and I want to develop a search engine within my own documents. For internet, your ChatGPT can answer the question in the internet. But for your own private documents, it can't understand what is present in your private documents. For that, you have to attach your private documents to our ChatGPT and you can develop a search engine for our private own PDF documents or text documents or CSV files or any other document format, any format, either PPTs or PDFs. So let us see the architecture overview of RAG here. Let us. It is a complicated diagram. I will show a simple diagram. I will say a simple diagram. See here, it is a RAG architecture. So there are two steps is there. So there is a engineer is there and the user is there. You are the user. You are the user who is using your LLM. See here, I want to ask questions your LLM, which is LLM is here, large language model. But I have to upload my documents, my PDF documents to the LLM. So your AI engineer will upload all our documents of Swarnandha Engineering Colleges to a large language model and store in a separate database called a vector database. See here, vector database is there. Vector DB. It is a database for storing all our documents, private documents, where your LLM does not know anything about your documents. So you have to store in a proper way. You can't store all the documents at once. So you have to perform various steps for storing your documents in a vector databases so that your user or any user can ask questions on the databases. So for that, there is a technique called chunking. So here, let us see here. See here, this diagram shows you. See, this is a PDF file is there. The same diagram I have written I have drawn a different way. Your PDF document is there. this PDF document I will load using document loaders. And this document I will split into chunks. It's called chunking. Suppose chunking means dividing your pages into small paragraphs. So one chunk contains 2 paragraphs. The second chunk contains the next 3 to 4 paragraphs. Like that, I will divide your document into small sections called chunks. So that is called text chunk. See here, because your LLM can't process the entire documents at a single times. So you have to give it piece by piece, so that it will be stored in a vector databases, and our LLM can understand every piece in a sequential manner. So that is called chunking the data. So I will use text chunking. So these chunks, what I will do, I will see this is text chunks. No text I can't give for the LLM, because you have to convert your text into vectors. That is called embedding techniques. So every text chunk, which is a piece of text, I will convert into vectors using embedding techniques. So every text I will give for the embedding generation model, where I will convert into embeddings, are called word vectors. They are called word vectors. So embedding is nothing but embedding vector, which is related to test chunk 1. This embedding belongs to text chunk 2. This embedding belongs to text chunk 3. Like that, for every chunk, I will have a separate embedding vector, which is representing your text into vectors. I told you, no, word embedding techniques. For every word, there will be a representation in a digital format. So these embeddings, which are nothing but chunk embeddings, I will store in a vector databases. So this is the database where all our chunks, which are nothing but pieces of text of your whole document, will be stored. So this is the place where you will store all the your private documents in the form of chunks. Okay. Next, suppose this is the user here. User is here. See, user is here. See, user is here. This user, what you will do, you will ask a question. See, this query is related to this user. He is asking a question with the vector database. This query also may be a question. What is the salary of Ramesh in Sonanda College? It is a query. This query I will convert into embedding format, because this is also a text, no? So I will convert into a vector, and that vector I will search for the relevant content in the vector databases. That is called the private documents you stored already in the vector databases. So related to Ramesh, you will try to extract what are the chunks which are having close to Ramesh. So that chunk should contain the word Ramesh. So it will try to find out the similar words, similar paragraphs, or similar chunks related to Ramesh. So those context will be extracted, and I'm finding the top k matches of Ramesh. Find the salary of Ramesh. So Ramesh is a word. So it will compare all the words of Ramesh and all the words of salary in the vector databases. So which words are having Ramesh and salary? Those context will be extracted from the vector databases, and that will be combined with the query and the top k data chunks from the vector databases, and that information I will give for the LLM. This LLM will contain your text chunks, your query, and the prompt, and it will answer based on the chunks it is retrieved from the vector databases. So it is called RAG, retrieval augment generation. Here I am giving LLM extra information called the chunks, the top K context related to Ramesh. The query is what is salary of Ramesh here. So for this Ramesh, it is trying to getting the most relevant similar context of Ramesh, and that text chunks will be given for LLM, and that LLM will generate the answer for the user. So here, without this, the vector databases, your LLM can't give answer for this single query. So if you give the query for LLM, what is the salary of Ramesh, it can't know. So based on the context, it is retrieving from vector databases, by finding the similarity of that query, it is able to give the response. So like that, you are augmenting the LLM. So it is called retrieval. For retrieving the answer, you are augmenting the LLMs. Augmenting means adding some extra context or adding some extra information, adding some extra knowledge base for the LLM so that it can generate the answer based on the context it is retrieved from the vector databases where you stored the PDF documents of our own data. So it is the main logic for performing RAG methodology for developing a search engine using LLMs. So this is the very, very important concept every company is developing. So there are many methods for developing RAG. It is a simple base method. What vector database you use? There are many vector databases. What type of database you are using? What type of, how you are splitting the chunks? So it is also very important how you splitting the chunks and what type of embedding technique you are using and how you are searching. You are performing a similarity search, how we are calculating the similarity with the query and the content in the vector databases, how we are calculating whether you are using cosine similarity or distance metric for finding the closest information for the query you are asking. So how to, if you get the content close to the query only, your LLM is able to answer. Suppose if you retrieve the data chunks which are not related to the query, and your LLM is will not be able to generate the response. This is the these techniques you should carefully select while developing a RAG method for developing a search engine. You can develop your own. You can do a project in your college using a RAG methodology. How to perform, how to develop a search engine. Suppose if you ask a question, your LLM is able to generate the answer for our private documents. What documents you upload? You can upload your document, a big document, a big book, which is written by you. You have written only the book. Suppose if you upload your book to LLM, if you ask questions on your book only, it is able to answer the question. How it is able to answer the question of your own book where it is not available in public. So using this technique, you can generate any search engine to retrieve the response. See here, chunking documents, chunking, document splitting. See, these are the documents, PDF files. These are PDF files, these are CSV files, JSON files. I'm splitting into separate chunks. It is called chunking. And then I'm doing embedding. So these are the representation of your text in floating point numbers. And you are storing in a vector databases. So loading your data first using data loaders. Splitting is nothing but chunking the text, and embedding it is embedding the your splitted chunks and storing in a vector databases. See, this is the way of retrieving. See here, suppose if you ask a query, the question is there. Question, I'm selecting the top chunks, and that chunks will be added to a prompt, and this prompt I'm giving for LLM to generate a response. So this is a RAG. What is RAG means? You are adding this extra knowledge base, all these chunks to the LLM for generate the answer. So it is not generate the answer only based on the question. Based on the question, based on the context, it is retrieved from the vector databases. It is able to generate the answer. This is the way of developing a RAG methodology. So coming to agents, agents are nothing but suppose you want information from ChatGPT about what is the weather at Hyderabad at Manikonda now. If you ask that question to your ChatGPT, it is unable to give the response. It will say you, I don't know the present temperature now because I don't have the information. Suppose you ask a question, calculate the value of 4.2 exponential 5. If you ask a mathematical question, your LLM will say it will give a wrong output. Means your LLM can give output only the data which is present or which is already trained. It can't give the response for the real-time data. So for that, you need some agents. Means agents are nothing but a third-party tool which will gather data from the external data sources. It will go there and fetch the data, and after fetching data from the external sources, and that data it will give to LLM, and the LLM will use the data to generate the answers. So agents are nothing but some mediators which will supply material, which will supply information to the LLMs. So how to define the agents? Agents are nothing but a helping hand, because your chat GPT model does not know the present temperature now. So for that they will use a tool called weather API tool, weather API wrapper. Suppose it want to search in internet, because your chat GPT is trained only data present before 2021. Suppose it want to get real-time stock, what is the stock price of IBM? For that it will use search, Google search engines, where it is nothing but a tool or agent, where that tool will try to go to your stock price website, and it will grab the IBM stock ratings now, and it will give the data to LLM, and that LLM will generate the response. So agents are nothing but external tools or external functions that will retrieve data from external resources, and that resources may be, it may go to a website, it may go to a Google Drive, it may go to a Gmails. So it will go to the locations where that data is present, and it will grab the data, and that data it will give to the LLM, and that LLM will use the data to answer the query you're asking. So it is called agents. So agents are more popular now. So how to construct the agents? And that agents, they are defined in a library called LangChain. LangChain is library everybody knows. It is a framework for developing generative AI problems. In LangChain, there are agents called, many agents called, one agent called React agent, which is called reasoning and acting, REACT agent, React agent, reasoning and acting agent. And other agents called LangGraph, which is a framework for constructing a graph type of structure for retrieving data from external sources. And there is other framework called Crew AI. Crew AI is a third party framework which is developed by a team called Crew, and that also we can develop multi agents. See, I'm saying only a single agent. Suppose you want multiple agents which are working together, means multiple people solving the problem and giving a solution. So like that you can develop a multiple agents separately, and those agents will interact with each other and try to get the data from external sources. They will interact and give the response to LLM, and that LLM will generate the response. Using Crew AI, we can develop a multi-agentic frameworks, and other framework is there called AutoGen, which is developed by Microsoft. It is also a framework. So these are the different frameworks for developing agents in AI. Let us see a simple. See here, this diagram shows a simple agent. Suppose you want to purchase a burger. See here, a customer is there. He is placing order. Online order is there. So he is placing a burger from a restaurant. See what are the steps? First, the customer will place an order, and it will travel to restaurant, and he will collect that agent will travel to restaurant. He will collect the pizza from the restaurant, and it will pay the price, and it will give the supplier. See how the agent is there. The agent which gets a pizza from a restaurant. So first is place order agent, process the order, assemble the pizza, cooking the pizza, deliver the pizza, collect payment. So like that, there are various agents which are whether steps are there, whether various functions which are operated by the agents for performing that task. So how an agent will go and fetch a burger from the restaurant, the same way your agents in AI will fetch data from the resources. See, he has fetched the burger from a restaurant. Same way, agents will fetch data from external resources, maybe a Google Drive, maybe a Google, maybe some repository, maybe some APIs, weather APIs or search engines. So it will use all the search engines or whatever information it needs. It uses that APIs to fetch data. So this is the hot area for implementation in IT industry. So we are developing agents for doing various tasks. So no need to use AI or a AI model separately. So you can add many agents around that LLM model where they will work on behalf of the LLMs, and they will gather information from the external sources so that the LLM or a chat GPT can generate the answer even though it is not trained on the data previously. So that is the use of agents. Suppose if you want to train your LLM every time, you need a lot of investment is there for training your LLM again. So nobody will train LLM. People are using agents for helping your LLM for the data it has not trained previously. So that's the main application of agentic AI, where you can do anything, any task, you can make your LLM to perform by using proper agents properly. So that is the final concept I can deliver to you. Any questions, please ask me. Hello.
Yes, sir.
Any questions, anybody?
Okay, thank you, Balakrishna sir. And some people they are asking the code and content. Definitely, we will share the code and content very soon.
Okay, I will share with you.
Okay, Madam.
Yes, sir.
Uma
Yes,
madam. So give the test instruction. The test should be open in the ATAL website. So please give the necessary instructions and conclude the session.
Okay, sure, sir. So before concluding, I just want to extend our heartfelt thanks to our speaker for delivering a highly informative and insightful session on AI-powered CTA along with practical applications by using RAG and agentic frameworks. So your expertise and clear explanations gave participants a deeper understanding of this critical domain and greatly enriched today's session, sir. And we are eager to engage with you again in future knowledge by sharing opportunities. Thank you, sir.
Thank you everybody for patiently listening. Actually, I could not deliver agentic better, but no time. So I given a hint of what is agents. That's all.
Okay. So tomorrow at 6:30 p.m. there is an online test. All participants be prepared. Whatever like up to now we have completed the sessions. From those PPTs we'll have some questionnaire. So you need to answer those questions, and if you are clear by the text, you can get this participant certification along with your 80% attendance. So tomorrow's session we start sharply at 2 p.m. So the first session will be 2 p.m. to 3:30 p.m. and thereafter it will be followed by 3:30 p.m. to 5 p.m. and 5 p.m. to 6:30 p.m. Okay, everyone clear?
Madam.
The test will be from 6:30 p.m. to 7:30 p.m. Madam. 1 hour
Madam.
session.
Madam.
Yes, sir. Yes, sir.
Another update, madam. They have to write ATAL test from through ATAL portal only.
Yes, sir. Once we share
Not
the
Google form will be given.
okay, sir. So everyone, everyone have to take your test in ATAL FDP site only.
Okay, madam.
Okay, sir. So any more questions? Okay. Thank you. Thank you, everyone. So tomorrow we'll meet you at afternoon 2 p.m.
Okay, madam. Thank you.
Okay, sir. Thank you, sir.
Hello, sir.
Azure.
Can I close the meeting, sir?
Close, you can close.
Okay, sir.